In this video, we're going to continue our work in Chapter 5, where we were working with bootstrap distributions. And so far, we've used bootstrap distributions to construct confidence intervals to estimate things such as difference in means between two independent samples, difference in means between matched pair samples, difference in proportions. So let's see how we can extend bootstrap distributions to do estimates with other statistics and what may or may not be different about some of these other statistics. And so the example I want to take a look at now is going to involve a data set called Verizon. And so Verizon, of course, they are a telephone company, wireless company. And so they provide manage and maintain telephone lines for large parts of the US. And so when that infrastructure is damaged, that doesn't just affect Verizon customers, that affects all telephone customers in that area. So we can group their customers into two categories called ILEC customers versus CLEC customers. And so an ILEC customer, that means these are the repair times that it took to make repairs for lines that affect Verizon customers, so they're actual customers, as opposed to competing local exchange carriers. And so when they make repairs on behalf of other companies that are serving other customers in that area, and these are called CLEC. And so a regulator might be concerned if Verizon is taking a really long time to respond for repairs that are helping other companies' customers. And so to see whether their repair times are unreasonable or not for other customers, they would compare it to how long did it take to make repairs for their own customers, so the ILEC customers. So the ingredients that we have here are, first of all, we have the data set, which is Verizon, and we've got two variables that we are interested in. How long was the repair time? And we want to compare this across the two different groups of customers. So the variable for customers is groups. And in fact, that data set contains only these two variables. So we've got time and we've got group. And maybe we'll see why here we might want to consider the ratio of these two means as opposed to the difference in the two means. But let's first get some estimates for the data that we're working with. And so as you can see here, they made a lot more repairs for their own customers. There's 1,664 ILEC observations in this data set compared to just 23 CLEC customers. So that would be the repairs that they made on behalf of another carrier. So first I want to subset the data into two groups. So rather than have it all in one data set, I want to split it up so that I've got just the ILEC customers in one group and just the CLEC customers in the other group. So this first line of code is going to create the subset of ILEC, their own customers. And so the variable that we want to select for that data set is going to be time. And the way that we're going to choose which times we're going to pick is going to be if the group variable has a value which is equal to ILEC. And the drop true means we're going to lose a header in this variable so that the variable just contains the values, which is what we want. And we do the same for the CLEC customers. We're going to pull off the times, but now we're going to pull off the times just for the CLEC customers. So now we took this one data set and we split it so that the ILEC, this contains the 1,664 observations. The CLEC subset contains the 23 that fit in that category. And now we want to compare the ratio of these two means. So we can denote this estimate with a theta and a bar on top. And so on top, we're going to look at the mean of their own customers, repair time, and on the bottom, we're going to look at the mean of the repair times for the other competitors' customers. And here what we're trying to estimate is the actual true value for mu of ILEC over mu of CLEC. But again, we just have a sample worth of data. So if we're using R in this Verizon data set, then what I could first do is calculate the mean of their customers. So that would be time.ILEC. And then divide that by the mean of the times in the other group. And that other group was CLEC. So if you've got R open, can't hurt to practice this. And here, since we're all dealing with the same data, you can check that this ratio comes out to about 0.5095. So let's think about what this value tells us. So in other words, what we see is the mean for the ILEC customers, and I'm going to approximate that 0.5095 with 1/2. So what we can see is that based on this sample that the ILEC repair time was about half of the CLEC repair time. And so that might seem a little suspicious. That seems like, why is Verizon taking half as long to make repairs for their own customers compared to their competitors? And the reason why the regulators might be interested in looking at the ratios of these two things is because the repair times can span lots. So sometimes it's a really minor thing, and sometimes it might be a really major change. And so we won't necessarily want to look at the absolute difference in the repair times, but we might be interested in seeing like how much longer, what percentage of the time longer do the competitor customers have to wait compared to Verizon. And so from this, we can see that it's about, the other competitor customers wait about twice as long for repairs as Verizon customers do. So that seems a little suspicious. But again, here we shouldn't put all of our eggs in this basket. There's certainly randomness at play here. And so what amount of time is reasonable? What amount of error should we build into these sorts of estimates?